Okay, guys, few things are there like commands we use in networking, and what is ping command, what is trace RT. Okay, these are very important commands. We know all ipconfig command. Okay, we know ipconfig and ip all we know it, right? Get mac we know. Okay, so these are the 14 commands, and how to test the network using a ping command, that is also there. So we'll use in a troubleshooting. I will tell the commands. Now I'll start with the IP address and some basics point. First of all, we'll see, guys. We are all use TCP/IP protocol suite. We are all use TCP/IP protocol suites. Always remember. And we are all using a star topologies. We are using star topologies. We are all using star topology. We are all using TCP/IP protocol suite only, not SPX, IPX, or kind of stuff. That's the only in textbook. I never seen almost like I know the networking from almost like a 2008-9 onwards, at least to list. In from engineering means it is a little bit 1 or 2 years earlier, but at least I know CCNA from outside 2017. Sorry, not 2007. So obviously, right? So this is a protocol suite only we are learning. Remaining is just the names. So we learn TCP/IP protocol suite only we are using, not OSA, not any other things. OSA only for reference. We use star topology. So this is a star topology. So device is connected to a centralized device. It can be a hub or a switch. That's a star topology. And we use IP address type only, not the other kind of addressing type. So we use only IP address, and main important IP address is IPv4 address. IPv6 is in a certain networks. Some message. Sandeep Kumar. Okay. So here it is, IP address. So mainly we are using IPv4 version globally. Of course, from certain organization, certain connection. For example, you are using Geo, some Airtel connections, so like that. They use IPv6 also in a private sector or a certain area. Some countries completely IPv6 now. Okay, some are following mixer, some are following only IPv4, some are following IPv6. But whatever it is, we use IP address, and very important one is IPv4 now. Still, it is important. So what is this IP address, guys? It is a logical address. IP address is a logical address. MAC address is a physical address. IP address is logical address. IP address is uniquely identify a device in the network. Okay, so IP address uniquely identify a device in the network. IP address is not a unique address. IP address can change according to network. Okay, so IP address uniquely identify a device in the network. Guys, when you are telling that one, IP address is a uniquely identify a device in the network, don't tell off. If you said off means or some part, it is meaning will be changes. Uniquely identify a device in the network means in the network you have a devices, each device having a number that is called the IP address. See, this is the IP address. So each device we can identify while they are communicating each other. Okay, like PC1 want to communicate it to PC3, so it want to identify like address this particular device. We use IP address to do that is IP address. Okay, it's a not unique address. Unique means it's like only one address cannot be repeated again. Okay, so but IP address is, we cannot say unique address, but it is uniquely identify a device. So these IP addresses may change according to your network or network kind of stuff. Okay, so this is about your IP address, and one more is IP address and MAC address differences. What is IP address? Logical address. What is MAC address? It is a physical address. It is a physical address. Logical address and physical address. IP address, we can able to change an IP address either manually or automatically kind of stuff. But MAC address is once it is given, we cannot change. Who given? Manufacturer of NIC gave this IP address to MAC address, so we cannot change the IP MAC address. We cannot communicate with MAC address. We communicate with IP address, we cannot communicate with MAC address. Of course, all communications by IP address only. We use both IP address and MAC address in communication, but we are address someone. To address someone, we use IP address only. So in IP address, we have a private and public IP addresses. In MAC address, there is no private, no public. It is a fixed address. MAC address is only one type of MAC address, that is also it is 48-bit 12 hexadecimal. IP address, two versions are there currently. It is IPv4 and IPv6, 32-bit and 128-bit. Some people believe it is, nowadays we are using IPv6 because it's a new one, and IPv4 is become older and exhausted. It is not like that, guys. It's all depends upon the network and network service provider, routers and all. And some people think like because we are in India, that's why it is IPv4 because we are not that developed. And they are comparing with the countries like Japan, Germany, where they are using IPv6, China using IPv6. India is a waste country. India is an underdevelopment country, developing country, developed country. Okay. Guys, America is a very big country. The technology started actually from this networking technologies, at least. I'm not telling technology started, but at least there are behind this networking part, right? Still in America, they are using IPv4. The America entire networking is become IPv6 is not happened. Still, they are using IPv4. They're like the so many very rich countries, they're still using IPv4 also because their backend routers and all compatible with the IPv4 only, not with the IPv6. Okay, so do not put a only one thing and something. Okay, it is. Yeah, this is a difference between IP address and MAC address. So it's also a question. So what is IP address and MAC address? IP address is logical address. It is MAC address a physical address. So IP address can be changed based on your network, or we can change the IP address manually or by DHCP server. MAC address is given by manufacturer of NIC, and we cannot change the MAC address. And in IP address, we have a private and public addresses kind of stuff, classes, so much of thing is there, but we are not. There is nothing like in a MAC address. It is a fixed address. IP address used for both LAN and WAN communication. MAC address, whereas it is valid only in a LAN communication. Okay, of course, when you are communicating from one system to another system, one device to another device, so you are sending both your source IP address, destination IP address, source MAC address, and destination MAC address. But originally, you are addressing with the IP address only. MAC address is only for a certain security or some verification purpose. Not exactly can't communicate with the MAC address. So MAC address is a fixed for that 48-bit 12 hexa representation. IPv4 we have a versions, classes, and other things. So again in IP addresses, IPv4, IPv6. Okay. Okay. Now it is IPv4 and IPv6. IPv4 is 32-bit, 2 to the power of 32, 4.3 billion IP addresses. IPv4 represent in a decimal format. Example of IPv4 is 192.168.1.101. So you can see any IP address, it is look like a 4 parts divided. Okay, IP address is look like a 4 parts divided with a dot. 4 parts are divided with a dot. It means total IP address is 32-bit. Means this entire part is 32-bit. If you written in the straight binary form, it is 32-bit. And you divide into 4 parts. It means each part is a 8-bit. Each part is a 8-bit. That is called as a octet. So if you see here, this is the first octet, second octet, third octet, and fourth octet. Always remember the name: first octet, second octet, third octet, and fourth octet. Each octet is divided by dot. That's why we have to read like this: 192.168.1.101. So as I said, it is each one is an octet, means 8-bit. 2 to the power of 8 is 256. Then it is a 0 to 255. Guys, if you count the numbers count like this: 0 to 5, 6 numbers; 0 to 9, 10 members; 0 to 15, 16 numbers; 0 to 2, 0 to 2012, it is a 3 numbers. So 256 in number, but it is 0 to 255. It means each octet size is 0 to 255 maximum. Means each part you will get a maximum of 255. You cannot use more than 255 in a single octet. Not even a 256. So highest number in each octet is 255. So if you got an IP address and someone asks you, is it a valid IP or not? First of all, see the each octet and check any octet is more than 255, it is invalid. Any octet, it is more than 255, it is invalid. So other rules are there, but it is simple to understand, simple to notify. Okay. Next one, see the first one we call it as the first octet, second octet, third octet, and fourth octet. The first one is WXYZ. Sorry. First octet, second octet, third octet, fourth octet. 4 octets are there. Each octet is 0 to 255 range. Okay. Some people, for making more easy, they put a WXYZ. Why WXYZ? To easy to remember, it's a W part, this is X part, this is Y part kind of stuff. Either you can use any notation, guys. First important is for understanding. Which way you understand, that way is always the best. Which way you can able to simplify and you do faster calculation and all, that is the best method always. For example, I have a cycle and I have a bike. So in that road or in the situation, I can go by cycle, I can reach it, or maybe bike is faster. But my driving is better with the cycle, not with the bike. Then which is the best? So cycle is best for me. So what's our story? It is, guys. So your IP addresses start with 0.0.0 and end with 255.255.255.255. So 0.0.0 is the first IP address in the IPv4 series. 0.0.0 is the first IP address. And what is the last IP address is a 255.255.255.255. Okay, each IP address, sorry, this is the total range. Okay, so you're starting 0.0.0, next one is 0.0.0.1, 2, 3, 4, 5, it goes up to 0.0.0, 254 and 255, that is last. Then next number automatically becomes 0.0.1.0. Why not 256? As I already tell, each octet is only up maximum 255 because it's a binary allocation. it is not our allocation. Okay, it is a binary Y we can able to take. So 255 means 8 ones. In binary, it is a 8 ones. 0 means 8 zeros. 255 means 8 ones. 254 means 7 ones continuously, first from starting 1 1 1 1 like that, it is 7 ones, last is 0, last is become 1, it is 255. Okay, so next one is 0.0.1.0, 0.0.1.1, 1.2, 1.3, 1.4, finally 1.254, 1.255, then it become 2.0. It keep goes like that, guys. So finally we reach like a 255.255.255. That is the last IP in the. Ignore this one. I don't know why I type for a testing purpose or something like that. Here in a IP addresses, there is a few points are there. So I'm not actually going to. Okay. So in IPv4, there is an IP address, especially like 127.0.0.1. That is a loopback or a local host address. Don't forget this point, guys. 127.0.0.1 is a loopback or a local host address. It is used to for a self-testing purpose or itself kind of stuff. So what is my local address? What is my local host address? 127.0.0.1. Where we use this kind of stuff, see, look at here. I have 5 computers, A, B, C, D, E, totally 5 computers. Each computer having an IP address 192.168.1.101, 102, 103, 123, 137. So EPC is in blue color, that is 137. Okay, A, B, C, D, E, all are in this, are connected to network having an IP address and unique IP address. It is 101, 102, 103, 123, 137. It's like it. Local host address. What is this? Each PC having an IP address and also having another IP which is common for each and every PC. Every PC having this. What are the IP address you are having to communicate one system to another system? Why we need this IP address? For A want to communicate B. How to put it? Ping or some protocol, whatever it is. 192.168.1.102 because B is a destination. For example, A want to communicate it to D. Then it will send a packet to 192.168.1.123. For example, B want to send a packet to B only, not A, C, D. B want to send a packet to B only. Then what is the address? 127.0.0.1. That is enough. C want to send a packet to C only. Self packet, self sending, self communication, self pinging, self testing. Use 127.0.0.1 as a destination address. So that is what is a thing is I explained in the E. So we'll see, guys. I have an application. This is my PC. Okay, in this PC, I have installed some application. For example, it is a web related application like a Tomcat kind of stuff. Like I make it as a web server. So I want to test it. I want to configure it. I want to do something with it from my PC, from my PC. So I want to connect it to this web application or website or a Tomcat server, web server application, not web application. It is web server application. I want to connect. Then use localhost. Then use localhost name or IP address.
Hello, sir.
Yeah, tell me.
Sir, actually IP address is divided into 5 parts, and 127.0.0.1 is coming in the IP class 1. Yes, sir.
Yeah, class A.
Yes, class A, sir. But some of the computers using IP address class B, class C, class D, and that one also supporting that localhost 127.0.0.1. Why, sir? Because it's already their IP is starting from more than 127, like 224, like 192 dot something like this. Then again is supporting localhost like 127.0.0.1, sir.
Very good, very good. Guys, there is a we are using class A range, B range, C range only. So D is a multicast, E is R&D. We don't use it. So okay, A, B, C. Okay, A, B, C range we are using. When you see any IP address is mostly like 192, right? This part or 172. This part. Okay, not any other things we don't see in general, right? So because it's a private IP addresses, first of all, of course, in class C also we have a private IP 10 dot series. Okay, so this is a first of all this series because of it is a private IP means most of our home computers in the LAN network we use private IP address, not a public IP. Next one is the network range is bigger. Means normally in a home or a small offices you have 100 200 maximum computers, not more than it, right? 20 computers, 30 computers, 50 computers, 100 computers, 200 computers. The class C support up to 254 computers in a single logical network. For example, if I take like this kind of network, this is a 0, start with 1, end with 254 and end with 255. So then network will change. This one become 2.0, 2.0, sorry. So become 2.0. So become another network. So actually people don't understand that. So, there is a thing is there. We have to go on, then only we'll understand. Okay. So this is maximum 254 computers you can able to connect in a single logical network. Okay. So our computers are limited, then we use class C. And this is a private IP address range. This is class B. In a class B, these two are a host ranges. Almost 65,536, 34 computers you can able to connect it. It meaning is, so without wasting more, like you cross 200, you have 300 computers in the network, 500 computers in the network, 1,000 computers in the network, 5,000 computers in the network, or maybe you have a 6,000 computers or a 60,000 computers in the network. Still we can able to use this class. The size is bigger. Size bigger means like, you're going outside. You brought a very big bag and you purchase one egg or maybe one something like one small item, biscuit packet, 5 rupees biscuit packet. But bag is bigger because it's a waste. It's become wasted. Okay. So like depends upon your network size. People use to try to use the class. This is also same thing. And this is class A. Class A, 3 parts are network part. 3 parts are host part. Host. It's around 16 million 214. This is the biggest range. Means up to 16 million, more than 16 million devices we can connect in a single network. So it means for one single packet, you are carrying one truck. Okay, one big truck for a one single 5 rupees biscuit packet. So that's the comparison I'm trying to show you that, guys. And that is also very good question. Why we need a classes? So why we divide a network into classes? This is also one of the answer because of People need a network size based on their number of devices in the network. Okay, so that's why we divide it. And 127.0.0.1, that is again different concept. 127 is a class A only, and we may not use to communicate from one PC to another PC with 127 because it is a reserved IP. 127, yeah, where are we? Yeah, we have to tell about 127 again, guys. Look at here. Here I explained one example, so then same example I will try to explain. Guys, this is my Oracle application. It's usually it is happened to me, that's why I'm telling. This is a database application installed in this PC, and this PC having an IP address. For example, 172.16.0.15. 15. Okay, this is the IP address of this PC. So PCA. Now, this is an application I want to access from the client application. And where is the client? It is the client SQL plus or a SQL developer, some client application. So I want to connect from client application to server application. Okay. Which IP I have to use it? I use localhost IP address only. I don't require my network connected related IP address. Not required because it is a locally configured. Means within. Okay. For example, you have to say yourself hi. Is like, do you need a name or some specific thing is not required, right? Yourself, myself. You're saying myself. Myself means it is you only. It is you. There is no specific address. It is kind of stuff. So telling yourself, that is a self IP address. For example, I have another PC. From this PC, I want to access your application. From this PC, this is my SQL developer. Okay, some client application. I want to access this application. So what is the IP address I have to use? 172.16.0.15. So whose IP it is? This IP. Whose IP it is? Its IP only. And this PC also having a 127.0.0.1. If in case in this client I use this IP address, it's try to connect to itself only. Try to connect itself. I try to connect from here, it try to connect it to this one. If I try to connect from here to here using this address, it will connect it to B only. It connects B here, it connects to A here. And as I said, this PC, APC, A is a computer name, B is a computer name, A is a computer name, and B is also a computer name. But both computers having a common name called a localhost. Okay, localhost is not a terminology. Localhost is a computer name of the name, computer name. Every computer name is localhost only. Every computer name is localhost. Even if you use a Unix operating system, a Linux operating system, the computer name is localhost and the IP address, local IP address is 127.0.0.1. It is reserved as for a loopback or a localhost IP address. When you are communicating to yourself, like your application or your server application and your client, both are in the same server, you can use localhost name or a IP address is 127.0.0.1. But when you are communicating from other PC to this particular PC, application content PC, like you want to access from there to here, compulsory you have to use IP address of this APC. This is APC IP address, not VPC IP address, APC IP address. Okay guys, that's the difference. That's why I given a very big diagram like this. Can you see? EPC having same application I'm accessing from EPC. It is 127.0.0.1. So like a network related services, not direct app services, network related. See, web server or web application is there. You deploy into your local PC. You want to access, use the 127.0.0.1. Okay, another IP address is there that is called 0.0.0.0. That 0.0.0 is it's an unknown IP, reserved IP address for a certain process like a DHCP DORA process, default routing process. Okay, first of all, I will tell all about IPv4, then I will go to IPv6. Okay, then I will tell the classes, subnet mask also. At least main part will be completed. In IPv4, we have a unicast address, multicast addressing, broadcast type of communication is also there. Okay. We'll finish IPv6 now. So we'll go to IPv6 guys. IPv4 32-bit, IPv6 is 128, 2 to the power of 120, 3.4 billions of IP address. This is 3.4 into 10 to the power of 38. That many IP addresses. So IPv4 is a very limited IP addresses in entire range. In IPv6 is lot of IP addresses, billions of IP addresses. IPv4 is represented in decimal format. It is like a 192.168.1.1, 10.20.30.40 kind of stuff. It is there. But in IPv6, it's a hexadecimal format. So here is the calculation. There is a 32 hexa numbers we are using. How to calculate like a each one hexa number is 4 bit. Means because of 0 is a starting, F is last digit in a single hexadecimal numbers, that is a F. Next one is 10. Okay. So F means it is a in a binary it is a 4 bits. So 128 by 4 it is 32 hexadecimal numbers. There is a 32 hexadecimal numbers. 4. Okay. So each 4 of the hexadecimal number as a single block, which is each block is divided by colon. So totally 32 hexadecimals and divided by 4, 8 blocks will be created. So each four of the hexadecimal numbers become a one block. Can you see like this? This is one block, one block, one block, one block, one block, one block. Okay, leading zeros and other zeros we can combine and we'll make it as a one. That is x's will separately do it. Yeah, here it is, you can see. So one block, one block, one block. Of course, in IPv4 we have a loopback address. Our localhost address is 127.0.0.1. In IPv6 it's a colon 1. It is a colon 1. In IPv6 the 0.0.0. in the IPv4 as unknown array. It is used to get IP address from DHCP default routing part. So it's represent in the colon in the IPv6. Just a colon, nothing is there. It meaning is all are zeros. Colon means all from starting onwards all are zeros. Last one is one. Colon 1. So in IPv6 you have a unicast type of communication, multicast addressing, any cast of communication is also there. In IPv6 there is a 4 or 5 type of IP addresses are there, division is there, but I'm telling only two mainly. One is global unicast. Global unicast IP addresses are a public type of IP address to communicate outside of your LAN communication or through internet you are communicating. You need a public IP address. But to communicate within the LAN, within the private network, link local IP address is enough. This link local IP address is given by system using the NIC's MAC address. Okay, so we can use the link local IP address to communicate within the LAN. Okay, so it's, if you see FE80 colon kind of stuff, that is a link local IP address. It is a private IP address. It works only within the LAN only. It is generated by system. Okay, it is generated by your computer based on your NIC's MAC address. So this is IPv4, IPv6. Okay, now it is 6:05. So no problem. So we'll continue and we'll finish it. If you take a break again, another 5-10 minutes. If I postpone again, another day. Okay. Yeah. Your IPv4. So actually IPv4 is, we can see IPv4 0.0.0.0 to 255.255.255.255. Totally 4 octets. Start with the 0.0.0 and 0.0.1, 2, 3, 4 like that. And finally we reach 255, 255, 255, 255. This is total range of your 4.3 billion IP addresses approximately. And these IP addresses divided into the classes, so based on the different purposes. So those classes are class A, class B, class C, class D. You have an IP address and you want to decide which class it is. Take the first octet part. You have seen an IP address and see the first octet, first part of IP address, first octet. See the first octet and check with the range. Okay, and then you can understand which class of it is. Class A, the range is 0 to 127. In certain textbook, it shows 1 to 126. Of course, we know the reason. 127 we cannot assign to any device. That is, our guy asked one question. That is a very good question, sir. Why we are not using 127 to assign an PCs? We are seeing only class C, class B kind of stuff also. Okay. So 127.0.0.1 is a local host or loopback address. Any which ways 127 series entirely we don't use it. Okay. So these type of IP addresses are reserved IP addresses. Next one is 0.0.0. It is unknown device kind of stuff, or it can be used as a default routing and other kind of stuff. Okay. So any which ways, 0 series also we are not using. 127 series also we are not using. Means we cannot assign to any. We cannot assign these ranges to any regular desktops. It is used by services or used by itself. That's why 1 to 126 is written, but both are correct, guys. 0 to 127. Just explain why it is 0 to 127. 127 is a reserved IP address, and 127.0.0.1 is a loopback or localhost address. And the entire 127 series we are not using, means we can't assign to a device. Next 0.0.0, again that is also reserved IP and used in a certain places. So we don't use it for a regular communication. And the adapter is not accept that kind of IP addresses anyway. Class B 128 to 171, Class C 127 to 223, Class D 224 to 239, Class E 242 to 255. Class E is a 242 to 55. It is for R&D. From my childhood, it is showing R&D only. So still we don't know where we use. Maybe they use in some special places. Class D is a multicast addressing. So we use this in a certain protocols like RIP, AGRP kind of stuff. They use this multicast addressing to distribute their routing tables. And also we use it for installing applications and operating system from one server to multiple hosts. That is a multicast addressing. But we cannot assign this class D and class E to any computer. It won't accept. It only accepted one is class A, class B, class C IP ranges only, because it is a unique cast. You want to assign an IP address to your device, you can pick any IP address from class A, class B, class C. Of course, there is underline rules are there. Okay, but generally I'm telling, so you want to configure a IP address from class A or class B, class C, you can configure. Except you, but remaining you can do it. Class D and E we cannot assign. Okay guys, this is for identification of IP address based on their first octet, right? So you can see 120.9.200.1. You have to look at only first octet. Do not see any other octets. You want to find class only. If in case there is a mistake is happened, then we can identify it is not that class. It is there is a mistake. Okay, so no problem. But still, so when you got an IP address, see the first octet and decide which class it is. So what is the first one class? 120.9.200.1. Okay. Class A, very good. It's a 120. 120 is in between 0 to 127. So it is a class A. Tell me about second one. 151, 280.2. No one is speaking. Class B. Okay, I will put it. So 197. Guys, are you not understanding this part? Classes or identification of classes? Are you muted or what? No. Okay. No problem. No one is talking. So I will talk myself and close this one. Okay. Identify which class it is. So based on the first octet of the IP address. Then also see the remaining octets should not be more than 255. Okay. See the first octet, check with the range, and identify which class of it. Every we are using only class A, class B, class C. Okay, as I said, like a class A, in a class A, we can connect only 254 IP addresses. In class B, we'll connect 65,534 devices. In class C, one single class C network can use 16 million devices. Okay, so how it is possible? Because our IP address is divided into network and host portions. So it is class C, first three are network portion, last one is host portion. There is a certain standard rule, that is device must be in the same network to communicate each other. Like if two computers are there, you connected a single switch, they will communicate. Physically and logically, they should be in the same network. Device must be in the same network to communicate each other. Device network portion must be same, or a network ID must be same. I'm talking in a simple LAN network, guys. But we are communicating to different IP addresses, right? Like a google.com, facebook.com. That's not follow your IP address. It contains its own IP address. But how you communicating? How we are communicating? Because based on the router. Router is an internetworking device. Router is a internetworking device. It connects to our more different networks. So router help you to reach the destination. Okay, so because router connected in different networks, then automatically we can able to communicate. Okay, But here in this LAN,
Hello.
now tell me.
Sir, you told that first three dot, these are the networks, and last one is the computer of any
Host.
users. Yeah,
Hmm.
host. But it's correct for all the cases, because I work in a Motorola company for manufacturing, sir. They are using 10.140 dot something like this one is coming, sir. Then
Okay.
10.140 only was the network, and remaining two dots was coming. That one is the user and host IP was there, sir. So it's not
And
correct for
that
all the
40,
cases, sir.
and these two are a change. This is not changing. This is constant, right?
Yeah, sir, that's telling.
And what is the subnet mask? Have you seen any subnet mask?
Subnet mask I not
Sure.
recognize.
No problem. No problem. Actually, 10 means which class?
Class A, sir.
Class
Class
A,
A.
right? Class A. Very good. Class A. Okay, yeah, this is the class A. The first version is network and remaining are host version with this subnet mask. Okay, so this is a default subnet mask of a class A. So 255 represent network version, means network represent ones, represent network, zeros represent host. So how it is, if you are convert this into binary, so then you will understand. But whatever it is, network, host. If you are using, check the subnet mask also. Okay. So for example, you take a 10 network, 10 dot 0 dot 0 dot 0. This is the network ID, starting IP address. Then 10 dot 0 dot 0 dot 1. This is the first IP address. Means from here, you can give it to devices like your computers are there. 3, 4, 5. Finally, you reach any which ways. You reach 10 dot 255 dot 255 dot 254. 254. It is a last. Up to here, we can assign to devices valid. Next is 10 dot 255, 255, 255 is a broadcast ID. Means your network is completed. This is your entire 10 network. In case 10 dot, sorry, what is the next number? It become 11. It's a different network now because the network ID is changed. So it is a network host, host, host. Okay, first one is changed automatically. It is become different network. Just in case you are maintaining in your organization, they are maintaining like this. So they making a try to become one. It's what I can able to see. Like they have more than 200 computers, and all are better to communicate with the here. But it's like not like a 16 million IP not required. I need a limited. So I can use different subnet mask using subnetting concept. Using subnetting concept. So I change the subnet mask like a class B subnet mask. So better to check once you can understand what is the limit. Okay, so here it is a class C. It's a 255.255.255.0. Class B, it is a 255.255.0.0, and class A 255.0.0.0 is a subnet mask. So same way, like in a number of what is the network portion and host portion. The first part is network portion. Second two parts are network portion in class B. In a class C, first three are network portion. Last one is a host portion. Like it depends upon your number of devices. You can choose class A, class B, class C. Guys, here it is. It is a class A IP address. This is a network portion. This is host portion. Here it is a compulsory understand. If two devices want to communicate each other, see it is PC1, PC2 want to communicate each other, their network portion must be same. It is a class B. First two are network portions. Make sure 16, 7, 172, 16. So both will communicate each other. Host can be changeable. PC3 and PC4, PC3 and PC4 IP address, sorry, you can see first portion is same, but here it is different. And PC1, PC2, PC3, first and second portions are same. Third portion is different, no problem, but is these three are will communicate each other. And it's not does not communicate with the PC4 because it's a different network. See it is first to our network portion. This is first portion is same, but second portion is changed. So check it. Class B, first two are network portions, remaining is host portions. Class A, Class B, Class C. Class A is a first portion only network portion. Class A, first portion only network portion. So see it is A, B, C, three computers are there. Here 101, 101, 100. So it is a different. So AB cannot communicate it to C. Same it is goes here. AB class C IP address. First portion, second portion, third portion is same, and 2 and 3 both will communicate each other. But here in this one, in a third portion, small changes, or maybe in this year, second portion, small changes, in first portion, small changes. So compulsory class C, first three portions must be same. Class B, first two portions must be same, and class A, first portion must be same too, in order to communicate in the network. Guys, I showed a subnet mask. What is a subnet mask? Subnet mask tell you what is your network ID. Tell subnet mask divide your IP address into network portion and host portion. Subnet mask use AND gate as a truth table and get truth table and do AND operations to get a your function. So this is the AND gate truth table. Both inputs are high, output is high. Any input is low, output is low. In this example, PCA having an IP address and there is a subnet mask. I want to find a network ID of this IP address. What I've done, so I convert entire data, entire numbers into binary, and I done AND operation between it. Then I put a result here. So this is a network ID. Okay, so here is a subnet mask for class A, class B. Class C is 255.0.0.0 and class B 255.255.0.0. Class C 255.255.255.0. So default subnet mask. Generally, we use default subnet mask for any kind of IP address, whether it is a class A or class B, class C. We use default subnet mask. It is called as a class full. It is called as a class full. Okay, we are using default subnet mask. In case you change the class, you change the class by changing, okay, changing subnet mask. You change the subnet mask, network ID will be changes. See, it is an example. This is a default subnet mask. This is a network ID, and this is the different subnet mask, and I calculate, I got a different network ID. Okay, so if you are change the subnet mask, compulsory you have to specify the subnet mask to, okay, compulsory you have to write a subnet mask, or you can represent the subnet mask in a slash notation also. Guys, if you don't tell what is your subnet mask means, you use default only. You have to assume it is a default subnet mask. Okay, if you change the subnet mask, you use some customized subnet mask, then compulsory you have to represent your subnet mask. You have to tell what is your subnet mask. Whether it is a class A or a class full or classless means whether you are using a default subnet mask or a different subnet mask, you can represent the subnet mask in the slash notation. That is also called as a prefix. This method we call it as a CRDR method, CIDR method, classless interdomain routing method. It's a prefix. 255.0.0.0, for example, in that one, 255 is a 8-bit number. So we have a 8 ones are there. So that's a /8. In 255, there is a 16 ones are there /16. 255 /24. So instead of writing a complete subnet mask, you can write in the slash notation like that, /24. You see here it is /25 because 255, totally 24 numbers. 128 is only one number in it. You can see in the table, it's a binary to decimal conversion only for a this way. So 1 all zeros, it's 128. 1 all zeros, 192. 111, 224. 1111 like 240. It's a conversion. Okay, so do not worry about it. Okay, yeah. What is these are all simple, guys. Again, IP addresses are divided into the classes: class A, class B, class C, class D, class E. Class C is a R&D, so we don't use it. Class B is a multicast. We don't assign to devices. So we use class A, class B, class C, that is a unicast address. Its ranges are 0 to 127, 128 to 191, 192 to 223, 224 to 239, 240 to 255. So we are using class A, class B, class C. In that one, we don't use 0.0.0. or a 0 series entirely, and also 127.0.0.1, which is reserved for a loopback or localhost address. And enter 127 also, we don't use it. Identify, compulsory note down some IP addresses or randomly create some IP address, then start identification, or you can identify from here also. Which class it is, that is important. Classification, which class we can identify based on the first octet, first number. Okay, so class A, class B, class C, there is a default subnet mask, class A 255.0.0.0, class B 255.255.0.0, class C 255.255.255.0. Class A first portion is network portion. So when you are having a two IP addresses, two or more IP addresses, the first portion is same, then they will communicate each other. You have a 2 or 3 computers, 5 computers, 10 computers. In order to communicate between two devices, their network portion must be same. In a class A, compulsory check the first one, first octet. In a class B, first 2 octet. In class C, first 3 octets are the network portion. So compulsory, so should be same, the same network. Okay. Network portion must be same. Of course, there is an importance of subnet mask is also there. These are the default subnet masks. In order to change network sizes and network IDs, we can also change the subnet mask. So you change the subnet mask, you will get a different network ID also possible. Any which ways, you two computers are there to communicate each other, they must have a same network ID. Same network ID, that's enough. Last part, guys. So just maximum 5-10 minutes I will complete. So then this part will be completed, IP address part. Okay. One or two small parts are no problem, but this is private IP address, guys. Private IP addresses are not non-routable IP addresses. It means you are in your home. You have seen already we discussed something like 192 IP addresses are there. Like that is, I said it is a private IP. So this is my network. This is my PC. Okay. In my network. or maybe I have a server in my network. Okay. From here to here communication. It is a simple LAN network. It is a simple LAN communication. I want to communicate from A to B, or B to C, or C to A. So we don't require any WAN connectivity, just a simple search and systems and connectivity. Do not think it's not applied for multiple things. What kind of IP address I will do it? So I will assign the IP address from these ranges. Actually, you are not connected to anyone. It means you can access, you can put any IP address, private or public, no problem. Okay, but you can take any IP from these ranges because it's a private IP, non-routable IP. No need to purchase or no need to pay for using any of these IP addresses. It's a completely free IP addresses. In a class A 10 series, entire 10 series is a private series, total 10 series. In class B, it's not 127 series. So 127.16 to 127.31. That range means 16, 17, 18 up to 31. It is a private IP addresses only. Again, 32 is not a private, 15 is also not private. Class C, it is 192, 168 kind of stuff. It is, you can see 192, 168 is 0.0. That is a class C private IP address. That's why when you see anyone's network in generally, home networks, we have seen 192.168 kind of stuff only, 1 dot or 0 dot or 2 dot kind of stuff only. Okay. So to communicate within the LAN, so private is enough because you don't need to pay for anything. For example, guys, this is the server. This is certain server is there. I want to access from C to the server. Both are in a LAN communication. It is a intra network. It is a intra network. So we don't require any public IP addresses. Private IP is enough. Okay. Next. Someone in the internet, not you, someone in the internet. So you are also connected to internet via router modem kind of stuff. Okay. So you're also connected. Now you want to access internet. So you establish the connectivity. Okay, someone is trying to access. You said someone is trying to access your server. Someone in the internet, so he's trying to access. He cannot access because you are in a private network. Your IP address is private IP address. If someone is in the internet want to access your PC through private IP address, they cannot reach you. They cannot reach you. Even they know your private IP, they cannot reach you because private IP addresses are non-routable IP addresses. Non-routable IP addresses. Okay, they cannot able to reach you through internet. I can reach from C to B, but a person from outside of internet, they cannot reach you. Then how to communicate? It is a very serious server. It is very important server. I have to access. I need access. Or you want this person to be accessed. Okay. So then what you do? You'll put a public IP now. You put a public. Instead of assigning this public IP address to the BPC, I'll use a translation method. Means this is already having a private IP. This is already configured with the private IP. Then I put this BPC's private IP address and BPC's public IP addresses. So in this router, I will configure. Originally, it is contains a private IP, but for a public, I use a public IP address. Means this PC can able to reach up to router using this public IP. and router to the PC, we can reach with a one private IP. Means outside is a public, inside it is a private. This concept we call it as a NAT, network address translation. This concept we call it as a NAT. Guys, understand?
So we can use router as well, right? Like to reach that.
Yeah, internally you are not having any public IP address. So any
Okay.
which ways we have to connect, like using modem, you are connecting to internet,
Hmm.
and you have to go to ISP. You have to go to ISP, okay, and ask ISP, I need a public IP. Whenever you want to communicate to public, you need a public IP address.
And from that public IP address, we can connect to this private IP address you are saying?
No, no, forget about private. I will tell. First
Hmm.
point is you want to communicate to the public, like you want to open google.com, facebook.com. First of all, we need a public IP address.
Okay, okay.
First one. Second one, for example, you have a server, okay, and like you're accessing google.com, like that you have something.com is there,
Okay.
and people will access your server, right? People will access server over the internet. So you want to get access, you need a public
Yes.
IP. Okay, understand, right? First 2 points.
Yes, sir. If in case I'll make it private, nobody will able to search that or
Very good. In case instead of using a public IP to the server, you put a private,
mm-hmm.
something 192 or 172, some IP you use it. People try to access with the private. That private is never be in the public. Which this private IP addresses not routable, non-routable in the public. So no one knows. Multiple people having same IP addresses in their privates. Okay. So compulsory a unique public IP address is required, which is we have to purchase or taken a rental also. There is some rental yearly you have to pay something is there, that kind of stuff. Okay. Not permanently purchasing, yearly some price will be there for a public IP. Okay. So 1 2 points. Good. Third point also I told. Yeah, you told. Okay. So that is a good point. It is if server having a private IP through public, no one able to access it. But my server having a private IP for public people, for public, I will tell this is my public IP address. But how to translate from like a people accessing with my public, and it should be translated to private over the certain thing like a router kind of stuff. That is called a NAT. So it maps your local IP to global IP, means public IP address, private to public. So very straightforward, I will tell. So you have a private IP address configured to the machines. These machines want to communicate in the public or communicated by public, communicated from internet users, or you want to communicate to someone, we need a public. So the private to public, like one private IP address is translated. Like how many servers are there? A, B, C. Three are there. All three want to communicate. All three want to communicate public. Means we have a three private IP addresses. It means you need a three public IP addresses. Okay. So what it will do? I will give you a map. A map is there or not? I didn't remember, but let's see. Simple like this is 192, 168, 5.2. Okay. So this is 192, 168. Yeah, anything I can take it. 5.3. This is 192, 168, 5.4. And I'm taking this is a router connected to my LAN, right? So that is 5.1. Okay, 192.168.5.1. So this is my for all these species default gateway is 5.1. For A, B, C, default gateway is 5.1 because it's a router's access. Okay. Now again, see this. I use this one. My private IP address in the router. So it will do this like 192.168.5.2, 192.168.5.3, 192.168.5.4, and it maps to some private IP address, right? So we'll write a private IP addresses here. Sorry, these are a private IP addresses in this side. Okay, so here it is in a public different IP. For example, it is 147.2.3.4 something now 147.2.3.5. Okay, so these are my public IP addresses. Something I purchase these public IP addresses to communicate in the public or communicating from public. Means through internet, people can access my devices and also I can access outside of my network. So instead of assigning these public IP addresses to devices, I map the private and inside IP addresses to outside IP addresses. IP address. Okay. So this called NAT, network address
अच्छा वाला नहीं बनाए हाँ
Okay, that's a good. Okay. What is it? NAT, network address translation. Network address translation maps internal means your private IP to external public IP addresses. So this is your internal IP and this is your public IP. So it is doing mapping. Okay. So you have a 10 servers means 10 private IP addresses. You need a 10 public IP addresses required. Okay. Understand guys, NAT concept. Guys, understand NAT concept. Last one, guys. It's only PAT is there. Okay. You may get a doubt. We are not purchase any public IP addresses, but we are all accessing internet, and we have checked our IP addresses are private IP addresses only, right? IP config. This is a private IP, right? It's not public. It's a private IP. But how you are able to access? Just to understand symbolic wire connection. So you can say Wi-Fi is there, sir. I don't know how to draw Wi-Fi. Okay, but how we are all having a public IP addresses. Sorry, we are all having a private IP addresses, but still we are able to get internet access. Guys, it is a one-way access only. It is a one kind of one-way access only. For example, you have a PC, A PC, B PC, C PC, and a D PC, for example. Each are having a private IP address. And this is the router. What it will do, for each PC, you cannot get a public IP. In generally, nowadays, lot of devices, right, in a home, laptops are there, at least two laptop, one laptop, two laptop, one desktop, mobile phones, TVs, tablets. Okay, so Each person having a one mobile and a tab is there and a TV is there. So number of devices increases. When number of devices increases, so we cannot assign an IP, we cannot purchase that many public IP addresses. So what they will do? So then they do like this. So this is one by one PC, like A PC, B PC. Someone put a music. Here it is, how it is translate. So for example, 192.168.1.11. That is A PC. 192.168.1.12. That is B PC. 192.168.1.13. CPC 192.168.1.14 DPC. 4 PCs are there. Means 4 public IP addresses how to purchase it. Instead of that one, so I'm taking only thing what's some public IP addresses like this. Only single public IP. I don't take more public IP. And how it is works, will show you. I will show you that. Okay. Example. First PC is sending a message. For example. Oh. Okay. So it mapped to the port number, some port number. Same port number will be assigned to public. So when it is sending, it sends like this. First, we'll reach the router with this IP address. In router, it maps like this, port number, and it will forward with this number like this. So the mapping is in the router, it forward with the public IP, and finally it reaches something like google.com, facebook.com, whatever it is, we reach it. And they will reply with your public IP. So you will reach with the public IP. Again, it is retranslate, then it will forward to A. Okay. So here it is. If you send, you will receive. If you don't send, you don't get anything. Okay. So here it is. For example, second PC is also sending some packet. Okay. And again, your public IP address is not changing. Your private IP address different, means one PC to another PC, IP is different, but public IP is always same for everyone. Okay, so it recognizes your private and public IP addresses based on their port numbers. So while retranslation. So once again, I will give you that thing, guys. Look at here. When you are sending, so your PC having a one private IP up to here. This is the private IP. In router, in translation method, so what it will do, it assign a port number to your IP address in private, and it send packet out with the public IP. So this is the private IP with the port number, and this is the public IP with the port number. It send a packet outside to internet with the public IP, and you reach the destination. And you will get a reply or outcome packet, right? So you are receiving a packet. So packet is received with your public IP, and here it is retranslated back to your private IP, and you will receive the packet. How it is matches with the port numbers, different random port numbers, depends upon your PCs and all. So random port numbers. It generated random port numbers. Okay. These port numbers are random port numbers. Okay. So all means all private IP addresses on single one public IP address. So you don't need to buy this public IP address also. Your ISP actually maintaining this one. ISP maintaining this one. Okay, maintaining this public IP address kind of concept. You know, when you put in a here, so what is my IP address? You type what is my IP address kind of stuff. You select what is my IP address. Your Google shows one IP address that is called your public IP. I cannot show because it is my public IP address. Of course, you cannot track me with that IP address because of which is my PC. I have a lot of PCs here, 2 PCs or 3 PCs are there, 4 mobiles are there, which is my PC. You cannot track. That is also public is not guaranteed because it's handling by ISP, not by my router. Okay, guys, this is we can able to communicate. Like B is communicating when it is with B IP address up to here, then it is mapped to one public IP with the port number and forward. When it is receiving, it receives with a public IP address and retranslate back to the private IP address of B, and we receive finally. Guys, only one thing is one question or one small clarification and we'll close. This is some outsider, means some person in the internet, and we have a server. For example, we have a server. This person want to access your machine. Machine, server, everything is same. Okay, even a computer is also comes under that. You want to access your server, and he got your public IP. He got your public IP. Now he's sending a request with the public IP. He can reach up to here, but this public IP is belongs to multiple private IP addresses, and that is also recognized by port numbers. That is also mapped in the port number form. Then what you will do? You cannot reach. It will be confused here only. So our internet is actually one-way type. Means you go and you get it. You send, you will get it. No one will send you something to you. That's why Indian network is almost safe without using more safe protocols. And we save a lot of IP addresses because we are using this technique. This technique called as a PAT technique, port address translation. Port address translation. Okay, the technique we call it as a port address translation. Why it is a port address translation? Also called as NAT overload. Why NAT overload? NAT means 1 to 1. NAT overload many to 1 directly. That is NAT overload. 10 devices, 10 private, 1 public. We can communicate from inside to outside, but outside person cannot communicate it to you because it's based on the mapping. Okay, all our internet we are using PAT technique only. Port address translation. Why port? We are using port mapping technique. Okay, guys, understand up to here?
Yes, sir.
Okay, I didn't explain APIPA, ping commands and all. That is, we'll see tomorrow. We'll start with some service desk kind of concept. Again, okay, no problem. I will start the service desk concept because that is very important. So first of all, we have to finish that. Okay, that's it for today, guys. Already it's around getting 7.